Okay, so I did the exploring rotations GeoGebra task. So it has 6 parts in it, from warm-up all the way to wrap-up. And so the first part gives you some movable points. So it has the point of rotation and then the points of the image, or pre-image, I should say. And all it asks you to do in this part is just to move them around and then go ahead and increase the angle of rotation. And it asks you to just describe what you see. So in this one, it's more just like you can explain that like, oh, well, the points to the right points on the Mona Lisa are always connected, and then the points on the left are forming this angle, and that, you can move the angle around, it'll move the image and pre-image around, increase it. When you bring it to 360, they overlap each other. Um, the size of one affects the size of the other, things like that. There's quite a few things that you could say. It's really open-ended. And then when you go to the next part, everything's locked. The point of rotation and the pre-image is locked. And so you have to go down here and it asks you to slowly start rotating the picture about the origin. So you use this to rotate it, and it asks you to find where B prime and C prime are whole numbers. And it turns out that they're all multiples of 90. So at 90, B prime, the image is whole numbers. Image, yeah. So if the pre-image is whole numbers, then like at 90, 180, 270, let me get 270, and then 360 are all where the image is also whole numbers. So in this one, you have to look at the directions. So you have to ask you to rotate at 90, and then record the pre-image points you see in the pre-image column, and then record the images in the image column. So in this one, you want to basically test out how different pre-images and images work out when it's a 90-degree rotation. So the best thing for students to do is to make the pre-image whole number coordinates instead of like these weird ones right here. So for example, they could do like B is -4, 5, C is 4, 3. Then they see that B prime, which is the image of 4, or the image of B is -5, -4, and C prime is -3, -4. And then you can just do that for a whole lot of different points for different sizes and everything, and fill out that or that table. So in this one you have to rotate it 180 degrees and do the same thing. So same type of rules apply. Go ahead and just move the pre-image to whole numbers, and then record the image coordinates for a couple points. So you could do like this one, and then this one, and then that one, and then that one, and you could even move them around to like the other sides, things like that, as long as they're both 180, or as long as the angle's 180. Same thing here. So 270, move it around however you want, and record it. And the reason we're recording all these points is because when we go to wrap up, you're finding a rule. So when you go to, let's start with 90. So when you go to 90, right, you have 3, -2, 6, -2. So what you want to do is you want to look at B and see what B prime is. So B is 3, -2. B prime is 2, 3. So as you can see, the X and Y are flipped. And so if Y in the pre-image is -2, then the Y in the image is 2. So we go from XY to -YX. Same with here. So the Y in this one is negative. The Y in the image is positive. So, well, the 2 in the image is positive, which is the Y in the original. So the rule is when you flip it 90 degrees, the image becomes -YX when going from the XY of the pre-image. Obviously, 0 is just they're on top of each other, so it's the same no matter what. And the students will be able to see all this stuff, uh, see the rules from their points that the points that they recorded. My mic maybe just cut out, but yeah. Um, so with 180, you move it, and you see that B is 4, 1. Well, B prime is -4, -1. So this one is just the rule is that it's negative x, negative y. So C is 6, 1, C prime is -6, 1. So it's the same coordinates, just the signs are flipped. Which makes sense because if you look at it, right, they're in the same, basically they're in opposite quadrants, but they're lying on the same point. So like 1, -1 for the y, for the x it's 3, and this one's -3. So it just flipped over the origin like that, and you can move it over. So it makes sense why it's just the same points, just negative. Um, okay, so then for 270, you go ahead and move that. Let me zoom in a little bit. So you see for B, it's 4, 2. For B prime, it's 2, -4. For C is 7, 2. C prime is 2, -7. So you see that you go from xy to y, -x. So this x becomes negative, and you flip it. Same with this, and it applies for everything. So B is -4, 2. B prime is 2, 4. And then for 360, it's the same. It's like when it says 0 degrees. They're just on top of each other. They're always the same. So yeah, that's the task. It's a decently long task. Yeah, there's quite a few parts to it. And yeah, I'm gonna move on to the standards. So I pulled up in the document. A lot of these standards that we're working with, since it's pretty much only to do with types of transformations, is in the Math 2 standards for geometry, or the geometry standards for Math 2. So this one says experiment with transformations in the plane, which is what we're doing. We're moving things around and changing the angle and all that stuff. And then the next one, given a whatever, like a shape, describe any reflection or rotation symmetry by actions that carry the figure onto itself. We're also doing stuff with that, identifying the center and angles of rotation symmetry. This is the big one right here, rotation symmetry right there, what we're talking about in this whole thing. And it says verify experimentally properties of rotations, reflections, and translation in terms of angles, circles, perpendicular lines, parallel lines, and line segments. That's also a big thing that we're doing when we're writing down the pre-image points and the image points. We're experimenting and trying to find a specific rule for um, rotational transformations. And we're also doing this one. Given a geometric figure in a rigid motion, find the image. So we have the pre-image and we're doing the image. Yep, so I think that's it. I've covered everything, and I think it's a great task if you're just now or just starting to learn about rotational transformations and symmetry. So, yep, this is something I'll definitely be using in my classroom.